How is oil trapped underground? How are oil traps formed? A geologic environment that allows for economically significant amounts of oil and gas to accumulate underground is termed an oil trap. Several geologic structures may act as oil traps, but all have two basic conditions in common. 1. A porous, permeable reservoir rock that will yield petroleum and natural gas in sufficient quantities to make drilling worthwhile. And 2. A cap rock, such as a shale, that is virtually impermeable to oil and gas. The cap rock blocks the upwardly mobile oil and gas and keeps the hydrocarbons from escaping at the surface. One of the simplest traps is an anticline, a folded, up-arching series of sedimentary strata. As the strata are bent, the rising oil and gas collect at the apex or top of the fold. Because of its lower density, the natural gas collects above the oil. Both rest upon the denser water that saturates the reservoir rock. One of the world's largest oil fields, El Nala in Saudi Arabia, is the result of an anticlinal trap, as is the famous Teapot Dome in Wyoming. Fault traps form when strata are displaced in such a manner as to bring a dipping reservoir rock into position opposite an impermeable bed. In this case, the upward migration of the oil and gas is halted where it encounters the fault. In the Gulf coastal plain region of the United States, important accumulations of oil occur in association with salt domes. Such areas have thick accumulations of sedimentary strata, including layers of rock salt. Salt occurring at great depths has been forced to rise in columns by the pressure of the overlying beds. These rising salt columns gradually deform the overlying strata. Because oil and gas migrate to the highest level possible, they accumulate in the upturned sandstone beds adjacent to the salt column. Yet another important geologic circumstance that may lead to significant accumulations of oil and gas is termed a stratigraphic trap. These oil-bearing structures result primarily from the original pattern of sedimentation, rather than the structural deformation. The stratigraphic trap exists because of a sloping bed of sandstone that thins to the point of disappearance. When the lid created by the cap rock is punctured by drilling, the oil and natural gas, which are under pressure, migrate from the pore spaces of the reservoir rock to the drill hole. On rare occasions, when fluid pressure is great, it may force oil up the drill hole to the surface, causing a gusher or oil fountain at the surface. Usually, however, a pump is required to lift the oil out. A drill hole is not the only means by which oil and gas can escape from a trap. Traps can be broken by natural forces. For example, earth movements may create fractures that allow the hydrocarbons and fluids to escape. The older the rock strata, the greater the chance that deformation or erosion has affected a trap. Indeed, not all ages of rock yield oil and gas in the same proportions. The greatest production comes from the youngest rocks, those of Cenozoic age. Older Mesozoic rocks produce considerably less, followed by even smaller yields from the still older Paleozoic strata. There is virtually no oil produced from the most ancient rocks, those of Precambrian age.